Hey, Algebra, I wanted to work out all these problems so that there'd be no question on how things are done. And the first thing I wanted to do is just really kind of jump into my thoughts on how to solve stuff. And I told you in class that it was with PEMDAS. Good old PEMDAS, which is parentheses, exponents, multiply, divide, add, and subtract, right? So what you do and how you learn this is you started over here with parentheses and you went this way in order to simplify, right? But once you have finished simplifying, well then, here's where you're at, right? Because you got all the way to the end of, PEMDAS. So then you can actually go this direction in order to solve, and you will solve by doing the opposite, okay? So what the heck does that mean? Well, let's zoom in over here. We have p plus 7 equals -9. And so on the left side of the equation is where we have our variable, and we want to get that by itself. And so we ask ourselves, like, okay, can it be simplified? And the answer is no, because we don't have any parentheses, we don't have any exponents, we don't have any multiplying. We do have adding, but you cannot add those two, so we're done simplifying. So now that means we're actually down right here. We are going to basically say, is there any adding or subtracting happening to the variable? Well, yeah, p is being added by 7. So we're now going to solve by doing the opposite. What's the opposite of plus 7? Minus 7. And if you're like, that seems like a lot of thinking in order to get to what we kind of already knew to be the case, that you were going to subtract 7, but you know what? Maybe you didn't know that was the case. And I'm just letting you know that that's how this works. And if you're like, wait, why did you subtract 7 on both sides? Why did you do it here and here? And it's because of our equal sign right here. If things are going to be equal, then you have to do them to both sides. You cannot just do them to one side. And we had a little bit of trickiness with one problem. I believe it was over here on the backside of this problem. So keep an eye on, okay, well, what was the trickiness with both sides? And we'll get to that in a little bit. So number 2, we want to get k by itself. It is on the right-hand side of this equation, and k is being subtracted by 2. We're going to add 2 to both sides. That cancels, and we now have k equals 2. And you might think, oh, okay, well, everything is going to be just one step. That's simple, and that's not necessarily the case. I think you already know that, but at any rate, I figured I should say it. What's happening to w? Hang on, let me back up. What's happening to w? It's being added by 1. So let's subtract 1 from both sides. And then you get w equals -11. Great. I'd mentioned that I wanted you to see, plug in actually check your answers every third problem. So let's actually zoom out. There's 3, 6, number 9, number 12, number 15, number 18, and 21. So we'll check all those. So how do you check? Well, so you're going to take this number, and wherever you see a W, you're just going to plug it in. So we have -10 equals -11 plus 1. I mean, that's all you got to do, because check this out. -11 plus 1 is -10. And does -10 equal -10? It sure does. Okay. G plus -3 equals 4. So they kind of tried to throw you a little curveball here, and then it says G plus -3, but it's really just G minus 3 equals 4. And what's the opposite of -3? Plus 3. So we get G equals 7. -14 equals -9 plus Q. Again, what's the opposite of a -9? Plus 9. And if you're like, wait, why opposite of -9? Because again, if we're going to solve, we're doing it by doing the opposite, okay? So we add 9 to both sides, and we get to Q. This is Q, that's Q. Q equals -5. And then right here, all right, this is actually our first one that we have to simplify before we can take a step. What are we going to simplify? If you have -12, that's really S. That's an S. As you can see, I don't really love S's. S plus 12 equals 15. so that now we can subtract 12 on both sides, and you get s equals 3. So how do you plug that in? Again, to kind of check your answer, you're going to do 3 minus negative 12 equals 15. 3 plus 12 equals 15. 15 equals 15. Yay. All right, shopping online, you find a skateboard that costs $124.99, which is $42.50 less than the price at a local store. Write and solve an equation to find the price at a local store. So here's how I'm going to look at this. Skateboard costs $124.99. That means whatever we've got, it equals $124.99. And I don't actually know the price of the local store, but I know that I've found one that is $42.50 less. And you might be thinking, well, how the heck would you know that? Yeah, I know. That's kind of a weird way of setting it up. But hey, there is the equation. And then write and solve it. You're just going to add $42.50. So I'm going to add $42.50 to both sides. And here's what I'm going to do. I'm going to borrow a penny from this one to make this $125. And then now down here I have $42.49. Makes this a lot easier. So 49 there. And then 761. That's how much the skateboard costs originally. Okay, solve these equations. Now this is kind of an example. I said number 8. Earlier I said number 19 is an example of like one that we had a little bit of a trick with. You could technically have had the same difficulty with number 8, because what happened is you could approach it by saying, listen, I'm going to subtract 4. And get that away from t, but that is not your only choice. So I'm going to do it this way, and then over here I'll do it the other way. So 8 equals t over negative 3 plus 4. And that way you'll kind of get two versions of what the heck am I talking about. And then now t is being divided by negative 3. You're going to multiply both sides by negative 3. And so t, since I write too giantly, t is now negative 12 for number 8. So now how would you do it another way? Well, right here, I could actually multiply by negative 3 now. And if you're like, wait, how? Aren't you supposed to do the adding and subtracting first? And this sort of is the answer, right? I mean, you would think, yes, you should do that first, but you get to kind of do things a little bit out of order as long as you're kind of careful. So what do I mean? Check this out. So I'm going to multiply the entire thing, both sides, by negative 3. And on the left side, we get negative 24. On the right side, here's what happens. This gets distributed here and here. So this negative 3 cancels out that negative 3, and we just get t. And then this negative 3 times positive 4 is negative 12. Okay? And then check this out. Now it's just a one step, like, hey, we add 12, we add 12. So basically, if we did the multiplying and dividing first, we're going to have to go ahead and do the adding and subtracting. I don't think there's a way around doing that, right? And notice we still get the same answer. We get t equals negative 12. So your order of operations can be messed with a little bit the more you kind of know what you're doing, right? And if you're a little confused on what just happened, the last thing I'll kind of point out is maybe it's a little bit about the fact that what happens when you multiply this by negative 3? Well, when you multiply a fraction by a whole number, you can write that whole number over 1, and then you just multiply straight across. So we get negative 3t on top, and on bottom we just get negative 3. And then since negative 3 divided by negative 3 is 1, that's why you're just left with t, which is why we were just left with t right here. Okay? Number 9 is a simpler version of that one. In fact, I'll try and speed up for you because I realize it's been 10 minutes and I've done less than 10 problems. But here we go. That's, by the way, something about my videos is that you don't have to watch every millisecond of it, because maybe you know what you know and you don't need to worry about it. Okay, so over here I distributed by -3, and that's because there was one term, two terms. I know this is going to be a little confusing, but over here it's still just one term. It's -2, and it's this term. You can't see me doing it. It's this entire thing is one term, okay? If we were to talk about just the top, that would be a different story, but here's what's about to happen. The -2's cancel, and we're left with p plus 5 equals -18. We're going to subtract 5, and we get p equals -23. We're supposed to check this one, so let's do -23 plus 5 divided by 2 equals 9. -23 plus 5 is -18 over 2. It's supposed to be -2. -2, because I was like, wait a second, that doesn't work out. But -18 divided by -2 is 9, and 9 sure does equal 9. Number 10. Oh, look, we should simplify. 3k plus 2k equals 60. You're always technically asking the question. You're always technically asking, can things simplify? In this situation, we get 5k equals 60. Divide by 5. Divide by 5. The 5's cancel, and you have k equals 12. 11. Ooh, we get some more simplifying. So on the left, it's simplified. On the right, these guys are like terms. So 12 minus 5p equals -43. I'm going to subtract 12. Why am I subtracting 12 and not doing something with the p? Well, because these two guys, this guy and this guy, they're like terms. They can be combined. They can be simplified. They can be mushed together. So we get -55 over here equals -5p, because this guy just drops straight down. We divide both sides by -5, and we get that p equals 11. Number 12, 28 equals 8b plus 13b minus 35. All right, so when I said I was going to speed up, I think I'm officially going to do that. So I'm going to add 35 to both sides, and I'm just saying it so that you have heard it, and then I'm not going to show it exactly. Divide both sides by 21, and I get b equals 3. If I were to plug it back in, I would put it here, and I would get 28 equals 8 times 3 plus 13 times 3 minus 35. This is 28, this is 24, this is 39 minus 35. Just for the sake of order, 39 minus 35 is 4. Hang on, I said just for the sake of order, just for the sake of ease. I could do this a lot faster in my head than I could do this. And guess what? When you're adding and subtracting, when it comes to PEMDAS, they are on the same level, right? So it doesn't really matter which ones you do first, as long as you just do them. And then 24 plus 4 is 28, and 28 equals 28. Yay, hooray, we got it right. Number 13, -11j minus 6 plus 3j equals -30. 11j and 3j, -11 I should say, is -8j minus 6 equals -30. Add -6, and you get -24. Divide both sides by -8, and you get j equals 3. A bill to landscape your yard is $7.20. I love word problems in algebra. I know, because I'm crazy, and because that is $720 can immediately be written like this. The word is an equal sign. I love it. And then, so it is $7.20. The materials cost $375. So check that out. That is an exact cost. There's no like per hour here. So maybe I'm getting a little ahead of myself by not reading the whole thing. Why don't I just read the whole thing? A bill to landscape your yard is $720. The materials cost $375, and the labor is $34.50 per hour. Okay, so we know that it costs $375 just to have these people come to your house. Well, with materials. And then it costs $34.50, so we're going to add that price, $34.50, and then it's for every, I'm going to write a giant H to just communicate. If you work 0 hours, you still paid for $375 of material. If you work 1 hour, it's $34.50 plus $33.75, right? But basically, they want to know how many hours did they work if the total bill was $720. Well, so we have our setup here. To find H, we're going to subtract $375 from both sides. $34.50 equals, let's see, can I do this in my head? I think it is $345. We'll do a little double check here. 5, yeah, $345. Oh, and then this division becomes pretty easy. We're going to divide both sides by $34.50. $34.50. They worked for 10 hours. And if you're like, how did you do that? How can I know? You can plug 10 right there, and you would get 345. And 345 plus 375 is 720. 15. 12 minus, here's the deal. It's just like these over here. There's just more steps, okay? So let's check this out. On the left side, we have parentheses. You can't do what's inside of those parentheses. So it's really, it seems like at this level, at this point in algebra, you don't do a whole lot of stuff in the parentheses. So anyway, 12 minus, we're actually going to distribute. We're going to multiply, okay? Because that is part of PEMDAS. Once you're done with parentheses, you go to exponents. And we don't have any exponents in this whole assignment, but we can multiply. And the alternative is dividing by this, and that's kind of ugly, so I don't want to do that. So negative 5 times 3r is 15r minus 10 equals 17. And then what you're going to do is combine like terms. 12 and negative 10 is 2. Minus 15r equals 17. I'm going to subtract 2. Negative 15r equals 15. Divide both sides by negative 15, and you get that r equals negative 1. And we could plug this back in to solve and double check that we did it right. 12 minus 5 times 3 times negative 1 plus 2 equals 17. Check it out. This is an example of stuff happening inside the parentheses that we can actually do. 3 times negative 1 is negative 3. And when you add 2, you get negative 1. So here's what we have. 12 minus 5 times negative 1. And so negative 5 times negative 1 is 5. 12 plus 5. And not just 5, but positive 5. And 12 plus 5 is 17. 17 equals 17. Yay! 16. We have nothing we can do inside these parentheses. Nothing we can do inside these parentheses. So we're going to distribute here. And we'll distribute here. And here's what we get. We get 3x minus 6 plus 10 minus 5x equals 16. On the left side, we can combine those two like terms to get negative 2x. We can combine these two like terms to get 4. And we still have 16. I'm going to subtract 4 to get 12. We can divide by negative 2 to get x is negative 6. 17. All right, now I'm going to speed up a little bit. Not showing all my work. I'm going to distribute negative 1. I'm going to distribute 4. I'm going to combine like terms. Negative v and 8v is 7v. Positive 4 and negative 36 is negative 32. I'm going to add 32 to get 35. I'm going to divide by 7 to get that v is 5. Same thing over here, just a little bit quicker. Distribute the 6 to get 6q minus 42. Distribute the 3 to get negative 12 plus 3q, and it equals 0. And you might be thinking, well, if it equals 0, then are we done? What we have to do is move all of the numbers away from the variables. So I'm first going to combine these two numbers to get negative 54, and then I'm going to combine these two to get 9q equals 0. I'm now going to add 54 and then divide by 9 to get the q equals 6. And then if you want to, I'll go ahead and do it to prove, to show your, I can't even think of what I'm trying to say, to prove that you got it correct, we're going to plug that 6 back into the q's. So we have 6 times 6 minus 7 minus 3 times 4 minus 6 equals nothing, equals 0. So what are we going to do? We're going to do 6 times negative 1 minus 3 times negative 2. This is negative 6. This is positive 6. That's 0 equals 0. Yay. Okay, so I told you we were going to reach one that like we had some, we made some mistakes on, but this is actually like, there's like a twofold reason for doing this. One, these were like the tricky ones to set up, just because they're in words and not all numbers. And then I kind of want to just show you the mistake version. Okay, so here we go. Let's break this down. We got 7 plus, stop. You can go ahead and write this. You can do 7 plus, or you could do plus 7. You know why you can do both? Because either way, you're going to basically accomplish the same thing. The quotient of, that means we're going to have a fraction. Okay? The quotient of a number. What number exactly? I don't know. It's just a number. A quotient of a number and 5. And then, like I told you, I love is negative 12. So check it out. I set it up 2 different ways. Either way is fine. Okay? It doesn't matter because they basically achieve the same thing. I mean, listen, what's this plus this? I don't know. But it looks just like that. It just happens to be written backwards. So I'm actually going to get rid of it so I can have some room to work. And here's where I'm going to display like the mistake. So you tell me, I'm literally telling you there's a mistake about to happen, and you tell me what happens. So I haven't made it yet. Here comes the mistake. You ready? What happened? I basically distributed, in fact, here, I'll pause the video, you answer, figure it out, now I'll tell you. So here's what happened. I didn't distribute it to that 7, okay? And if you're like, well, wait, shouldn't we have subtracted 7? You could have, and that was an option that you had. But I know that one person yesterday or whenever it was didn't do that, and they ran into some like, well, what the heck happened? So if we do it right, we get 35 plus x equals negative 60. We subtract 35 to get x equals negative 95. Could you have done it another way? Yeah. Again, you could have subtracted 7. So what you would have had is x over 5 equals negative, negative 19. And negative 19 times 5, you guessed it, negative 95. Okay. The difference of 3 times a number, so hang on, the difference, it's going to be a minus sign. I know you're thinking, really? That's how you're going to do this? Yeah, I'm going to do it. The difference of 3 times a number. Which number is that exactly? I don't know. But the difference of 3 times a number and half the number. So we have 3 steps here. It's the difference, a subtraction problem, the difference of this thing and this thing. And then you know my last part, I love it, is 60. So 3x minus 2x is 2.5x, and that equals 60. And then we can divide 60 by 2.5. I gotta be honest with you, I'm gonna do this over here. So let's see. I'm gonna do this thing where I do that. Twice, that's 50. We got, it's 24. Okay, cool. So x is 24. There are 24 2.5s in 60. All right. 8 times the difference. So just 8 times the difference of, so it looks like it's going to be like this. 8 times a subtraction problem, a number, and 3 is 40. 8 times x minus 3 equals 40. Now, if you were to try and read this, you would say 8 times x minus 3. Well, isn't that 8 times the difference of a number x and 3, and it equals 40? So how do you solve this? I'm going to solve it down here. So here we go. I'm going to distribute that 8. Actually, I don't have to distribute the 8, but I could have divided by 8. But let's not worry about that right now. I'm going to add 24 to get 64. I'm going to divide by 8 to get 8. All right, this last one, we talked about like the second day that we were going over some of this stuff. And so if it's not super duper fresh in your mind, here, pay attention. Find 3 consecutive odd integers that have the sum of negative 51. So there's our first odd integer. What? How is that our first odd integer? It's x. So like, let's pretend it was 3. Okay, so then what would the next odd integer be? It would be 5. Okay, so how could you represent that using x and whatnot? Well, 3 is just x. And then this one would have to be x plus 2. Because if this is x, then this has got to be 2 more than that, right? And then, oops, I'm undoing too much. And then the next odd integer would be x plus 4. Why is it plus 4? Because how do you get from 3 to 7? You would add 4, right? Okay, so now here's the thing. It says they have the sum. So sum means we're going to have an addition problem. Add all these things up, and it equals negative 51. And you might be thinking, how the heck can you add numbers and get negative 51? I think that's just something that kind of throws us off because we forget that you could add negative numbers. But here's what you're going to do. On the left side, on this side of the equation, we have x, x, and x. That's 3x because they're all being added, right? And then you have 2 and 4, they're being added, so that's 6. And it equals negative 51. We're going to subtract 6 from both sides, and we get, I'm going to do this right over here. We subtract 6 from both sides, and we get negative 57. And then we're going to divide both sides by 3, and we get negative 19. At least I think that's the case. 19 times 3 is 27, 2. There we go. All right. So then, here's what's up. Our first odd integer is negative 19. The next consecutive odd integer is negative 17, and the next odd integer after that is negative 15. There's our answers. If you're thinking, holy cow, it took this dude 30 minutes to do this entire thing, not really. I explained in hopefully great detail how to do all of these, and I even plugged in my answers and whatnot to show how to make sure you got it right. And just let me know if you got any questions. See ya.